Now what we saw just now in the previous video, that is called as a p-type semiconductor. It is called as a p-type semiconductor. Why p-type? Because the host atom is having 4 valence electrons and the impurity atom is having 3 valence electrons. So some kind of positivity is being experienced because electrons are deficient, is it not? So you are doping it with an electron deficient impurity. Okay, so there is some emptiness, there is some lack of electrons to satisfy the silicon atom. So this lack of electron is what is denoted by P. P means positive, right? So whenever an electron is lost, what is the atom getting? It is getting a positive charge. So it is called as p-type semiconductor. Now there is another type called N-type. Now what is this N-type? Now in this N-type semiconductor, N for more number of electrons, P for less number of valence electrons. That is, the impurity atom is having lesser number of valence electrons, that will give rise to p-type, and greater number of valence electrons will give rise to N-type. Now silicon is your host lattice, which is having 4 electrons in the valence shell, and the impurity atom that you are adding here, it is belonging to 15th group. That means it could be either phosphorus or arsenic or antimony, like that, right? So these are all having 5 valence electrons, whereas silicon is having only 4 valence electrons. Now say in the place of silicon, one arsenic atom has been introduced. Now it is having 5 valence electrons, 1, 2, 3, 4, 5. Now the 5th valence electron, it has nothing to get paired. सिलिकन के पास सिर्फ 4 इलेक्ट्रॉन्स है, वो चारों साइड सेटिस्फाई हो चुका है. So the extra electron of arsenic is responsible for conductivity. This gets delocalized in the solid lattice and that will be carrying current, or that will be responsible for conduction. So this is what you call it as N-type semiconductor. That is the difference between p-type and N-type. N-type is due to extra electrons of the impurity atom, whereas p-type may the conductivity is due to holes, electron holes, right? Now what are the applications of N-type and p-type semiconductor? This has been found to be used as a diode. Now what is a diode? It's a combination of p-type and N-type semiconductor, and it is used as a rectifier. You must have studied about all these things in your physics. Solar cell is an efficient photodiode. Where is it used? It is used in the conversion of light energy into electrical energy. Then transistors, they are sandwich semiconductors, PNP or NPN. These things must be familiar to you now, right? PNP, that is one layer of p-type semiconductor, then one layer of N-type, and then another layer of p-type. So this is what you call it as PNP or NPN. N-type, p-type, N-type. So 3 layers are there. Such transistors, where they are used to detect or amplify radio or audio signals. Now apart from this, there are also compounds which have revolutionized the semiconductor industry. How? The silicon is now in great demand and it's quite expensive also. So what they have come with alternatives. What kind of alternatives? They have started using 12-16 compounds and 13-15 compounds. Now what do you mean by 12-16 and 13-15? 12-16 means 2 valence electrons, 16th group means 6 valence electrons. So 2 plus 6 is equal to 8. 8 divided by 2 is 4. A combination of 12th group element and a 16th group element. So 2 elements are combined. Say for example cadmium selenide. Cadmium from 12th group, and selenium from the 16th group. Now this will give an average valency of 4. Same way this 13-15 compounds. 13-15. 13th group elements will have 3 valence electrons. 15th group elements will have 5 valence electrons. Again, it will show an average valency of 4. So such compounds in the place of silicon, it has been found to be very useful in semiconductor industry in the form of semiconductor devices. These compounds can be used in the place of silicon. So they have revolutionized the designs of semiconductor devices. What is the main reason behind it? Because they simulate an average valency of 4 like that of silicon, and hence they are highly useful. Yes, so this is about N-type and P-type semiconductors. Now in the next lesson we will see about electrical properties.